Hello all, welcome back to our channel. Today we are going to discuss about singular matrix and non-singular matrix and problems on singular and non-singular matrix. So first of all, our first definition is singular matrix. So a matrix is said to be a singular matrix if its determinant value is equal to 0. Therefore, the definition of a singular matrix is a matrix whose determinant is equal to 0 is said to be singular matrix. Singular matrix. So here a matrix whose determinant value is equal to 0, then we should call that matrix as a singular matrix. For example, if you consider one matrix A is equal to 4 minus 2 minus 6 3. If you find the determinant value for this given matrix A, that is det A, which is equal to mod of 4 minus 2 minus 6 3, then we have to find the value of determinant for the given matrix A by using the formula AD minus BC. So here A is 4, B is 3. So 4 3s are 12 minus B into C. Minus into minus plus 6 2s are 12. So 12 minus 12 is 0. Hence, the determinant of the given matrix A is 0. So we should call the given matrix A as a singular matrix. Now let us discuss about non-singular matrix. So these are the definitions which are important for your exam. So here for your exam purpose it will come for 1 mark question. So here non-singular matrix definition is a matrix whose determinant is non-zero. A matrix whose determinant is not equal to 0. Not equal to 0. Then we should call that matrix is said to be a non-singular matrix. So a matrix whose determinant is not equal to 0 is said to be non-singular matrix. For example, if you consider this matrix B is equal to 4 minus 7 5 minus 3. If you find the determinant value for the given matrix B, then you will get the answer as det B is equal to mod of 4 minus 7 5 minus 3. So here we should use same formula AD minus BC. So 4 into minus 3 is minus 12, minus 7 into 5 is minus 35. So minus into minus plus 35. So it will come as 35 minus 12 is 23. Therefore, det B is equal to 23, which is not equal to 0. So for any given matrix, if the determinant value is not equal to 0, then we should call that matrix as non-singular matrix. If the determinant value is equal to 0, then we should call that matrix as a singular matrix. So these are the important definitions of singular and non-singular matrices. Now let us see the definition of adjoint of a matrix, which is very important concept for your examination point of view. The transpose of the matrix formed by replacing the elements of a square matrix with the corresponding cofactors is called adjoint of a matrix. Adjoint of a matrix is denoted by ADJ of A. Short form of adjoint of A is ADJ of A. And adjoint of A formula is transpose of cofactor matrix. So this is very important formula. Therefore, adjoint of a matrix formula is transpose of a cofactor matrix. So after finding the transpose for the given cofactor matrix, then we should call that as adjoint of a matrix. After the concept of adjoint of a matrix, then we should discuss about inverse of a matrix. So here, inverse of a matrix. The operation of dividing one matrix directly by another does not exist in matrix theory. Therefore, the equivalent division of a unit matrix by any square matrix can be accomplished in most of the cases by a process known as inverse of a matrix. So the definition for inverse of a matrix is, if for a square matrix A there exists another matrix B such that AB equal to BA is equal to I, then the matrix A is said to be invertible to the matrix B, and the matrix B is called the inverse of A, and it is denoted by A inverse is equal to B. So the concept of a matrix or inverse of a matrix is useful in solving the simultaneous equations. Only square matrices possesses inverse. So it follows from the definition, if B is the inverse of A, then A is the inverse of B. It follows from the definition that A into A inverse is equal to A inverse into A is equal to I. So this is one property, and one second one is A inverse whole inverse is equal to A again. A inverse whole inverse is equal to A. Therefore, the inverse of a square matrix, if exists, then it is unique. The inverse of unit matrix is itself only. If A and B are two invertible square matrices of the same order, then AB whole inverse is equal to B inverse into A inverse. Then fourth property is A transpose whole inverse is equal to A inverse whole transpose. And in general case, A into B into C into D into so on up to Z inverse is equal to Z inverse, Y inverse, X inverse, so on up to B inverse into A inverse. Next, and in the last one is determinant of A inverse is equal to determinant of A whole inverse, det A whole inverse, which is equal to 1 by det A. So these are the 6 properties having in your inverse of a square matrix. Therefore, if A is a non-singular matrix. So for every non-singular matrix we exist inverse. If A is a non-singular matrix, for a singular matrix there does not exist A inverse. So if A is a non-singular matrix, then the formula to find inverse of A equal to A inverse is equal to adjoint of A divided by determinant of A. This is the formula we have to use to find A inverse for the given non-singular matrix. For every singular matrix there does not exist inverse for that singular matrix. Inverse only exists for non-singular matrices. Here we came to our last exercise in our matrices and determinants chapter. So here these are the review questions. So for first question is define singular matrix. So in the very beginning of our class only we have discussed about the definitions of singular matrix and non-singular matrix. So here define singular matrix means you have to write it as the determinant of a matrix is always 0. And define non-singular matrix means a determinant of a matrix is not equal to 0. Define adjoint of a matrix. Adjoint of a matrix is transpose of a cofactor matrix. Inverse of a matrix. Define inverse of a matrix is A inverse is equal to adjoint of A by determinant of A, where A is a non-singular matrix. Next, if A is equal to A, B, C, D, then find adjoint of A. If A is equal to A, B, C, D, then find A inverse. This is very important formula. You have to remember to find directly the adjoint and inverse for the 2 by 2 matrix. Let us discuss now. So here, if A is equal to A, B, C, D, which is a 2 by 2 matrix, here we have to find adjoint of A and determinant of A. This is 1 mark question. So here, A inverse is equal to formula we are having adjoint of A by determinant of A. So here adjoint of A is, we have to remember D minus B minus C A. So this is the adjoint for every 2 by 2 matrix, that is D minus B minus C A. Here we have replaced A with D, D with A. A and D ni interchange చేశాను వాటి ప్లేసెస్ని, అండ్ బీకి సికి ఉన్న సైన్స్ని ప్లస్ ఉంటే మైనస్ చేయండి, మైనస్ ఉంటే ప్లస్ చేయండి. సో సైన్ చేంజ్ చేయండి, ఏని డీని మాత్రం ఇంటర్చేంజ్ చేయండి. Divided by determinant of A. Already we have discussed about the determinant of a 2 by 2 matrix, which is equal to AD minus BC. So this is the formula to find adjoint of A and determinant of A, and we have to divide adjoint of A by determinant of A to get the value of A inverse. So here this is the last exercise in your matrices and determinants chapter. This is exercise 3.5. Here we have show that the matrix is a singular or non-singular matrix. Show that the matrix is a singular matrix. Some questions on singular matrix, some questions on non-singular matrix. So our next one is, so here if the matrix is a singular matrix, then find the value of x. So total 3 concepts you are having. If a matrix is a singular or non-singular, then we have to find any value which is missed in our question. Next question is find the adjoint and inverse of a 2 by 2 matrix. Here we have 2 by 2 matrices. Then find the adjoint and inverse if exists for the following matrices. So these are the 3 by 3 matrices. So at the end we are having show that AB whole inverse is equal to B inverse into A inverse, which is one of the property for inverse of a matrix. Show that A into A inverse is equal to A. Show that A into A inverse is equal to I. So these are the proofs we are having. So this is the end of our exercise 5. So by this, in a total we are having total 8 bits. So one by one let us discuss in our class. So here in our exercise 3.5, our first bit is show that the matrix is a non-singular matrix. Here I have taken 2 questions. Here matrix A is equal to 3, 4, 5, 7. So first of all let us find out the determinant for the given matrix A. So det A is equal to mod of 3, 4, 5, 7. Similarly, det B is equal to mod of 1, 1, minus 4, minus 5. Here we have to use for both the questions formula is AD minus BC. So here det A is equal to A into D is 3 into 7. 7 3s are 21 minus B into C is 5 4s are 20. 21 minus 20 is 1, which is not equal to 0. Therefore, matrix A is non-singular matrix. Similarly, det B, which is equal to AD minus BC. 1 into minus 5 is minus 5, minus of 1 into minus 4 is minus 4. So minus 5 plus 4 is minus 1, which is not equal to 0. Therefore, matrix B is also a non-singular matrix. So here we have proved the given 2 matrices are non-singular matrices. So in the next bit we are going to show that the given matrices are singular matrices. So here our second bit is show that the given matrices are singular matrices. So our first question is A is equal to 1, 1, 0, 0. So here we have to find the determinant for the given matrix. Det A is equal to mod of 1, 0, 1, 0, which is equal to AD minus BC. 1 into 0 is 0, minus 0 into 1 is 0. 0 minus 0 is 0. Since the determinant of the given matrix is 0, then we should call the given matrix A as a singular matrix. Our next question is A is equal to 1, 2, 3, 3, 4, 5, 4, 6, 8. So here we have to prove that the given matrix A is a singular matrix. So for this you have to use Laplace expansion. Laplace expansion. So already we have discussed about Laplace expansion in your previous class. So here det A is equal to mod of 1, 2, 3, 3, 4, 5, 4, 6, 8. So here this is mod. Here we have to consider plus, minus, plus. Here we are expanding in row 1. 1, 2, 3. So here 1 straight గా రో వైజ్ కాలం వైజ్ కట్ చేయండి. కట్ చేస్తే రిమైనింగ్ 4 ఎలిమెంట్స్ ఉన్నాయి కదా, ఆ 4 ఎలిమెంట్స్ రాయండి. అంటే దిస్ ఇస్ కాల్డ్ యాజ్ మైనర్ ఆఫ్ 1. 4, 5, 6, 8. దెన్ వీ హ్యావ్ టు రైట్ మైనర్ ఆఫ్ 2. అంటే 2కి కరస్పాండింగ్ రోస్ కరస్పాండింగ్ కాలమ్స్ కట్ చేస్తే ఇట్లా కట్ చేయండి. 2కి కట్ చేస్తే 3, 5, 4, 8. 3, 5, 4, 8. This is minor of 2. The next minor of 3. అంటే 3కి కరస్పాండింగ్ రోస్ కరస్పాండింగ్ కాలమ్స్ కట్ చేయండి. రిమైనింగ్ మిగిలిన 4 ఎలిమెంట్స్ వీ షుడ్ కాల్ ఇట్ యాజ్ మైనర్ ఆఫ్ 3. సో 3, 4, 4, 6. 3, 4, 4, 6. Like this you have to expand This expansion is known as Laplace expansion. Now we have to simplify. Already minorని సాల్వ్ చేయడానికి ఫార్ములా AD minus BC యూస్ చేయాలి. Therefore plus 1 bracket minus 2 bracket plus 3 bracket. So 8 4s are 32 minus B into C is 6 5s are 30. Next 8 3s are 24 minus 4 5s are 20. Next 6 3s are 18 minus 4 4s are 16. Like this you have to expand by using the formula for minor, that is AD minus BC. Then 1 into 32 minus 30 is 2 minus 2 into 24 minus 20 is 4 plus 3 into 18 minus 16 is 2. Then you have to solve 2 1s are 2 minus 2 4s are 8 plus 3 2s are 6. So 6 plus 2 is 8. 8 minus 8 is 0. Here the determinant for the given matrix A is 0. Hence we should call the given matrix A as a singular matrix. Like this you have to show or you have to prove whether the given matrix is a singular or non-singular. Let us discuss one more question on non-singular for a 3 by 3 matrix. That is A is equal to 1 2 2 2 1 2 2 2 1. Show that it is a non-singular. So here we have to prove that the given matrix is a non-singular matrix. So here this is a 3 by 3 matrix. Here we should prove that this matrix is a non-singular one. Here we have to find that A is equal to mod of 1 2 2 2 1 2 2 2 1. Again you have to use Laplace expansion plus minus plus 1 2 2 mod mod mod. Then you have to write their corresponding minors of 1 2 2. So 1 minor is 1 2 2 1. 2 minor is 2 2 2 1. Next 2 minor is again 2 1 2 2. Like this you have to write the minus for first row elements. Then we have to use the formula AD minus BC in order to expand the minors. So det A is equal to plus 1 bracket minus 2 bracket plus 2 bracket. Like this you have to expand. In the bracket you have to write AD minus BC values. So 1 1s are 1 minus 4 2 2s are 4. 1 2s are 2 minus 2 2s are 4. 2 2s are 4 minus 2 1s are 2. So like this you have to expand by using AD minus BC formula. Then we have to simplify. 1 into 1 minus 4 is minus 3. 2 minus 4 is minus 2. Minus 2 into minus 2 is plus 4. 4 minus 2 is 2. 2 into 2 is plus 4. So plus 4 will become 8. 8 minus 3 is 5, which is not equal to 0. Hence the det value for the given matrix is not equal to 0. Then we should call the given matrix A as a non-singular matrix. Here the det value for the given matrix is 0. Hence we should call this matrix A as a singular matrix. So like this you have to do in your exam. If a matrix is a 2 by 2 matrix or if a matrix is a 3 by 3 matrix, then we have to go for Laplace expansion. If a matrix is a 2 by 2 matrix, then we have to go for a minor expansion, that is AD minus BC. So like this you have to do your exercise problems. Then we are moving on to our third bit. Find adjoint and inverse of a given matrix. So here our third bit is find adjoint and inverse of a 2 by 2 matrix which is equal to 1 2 3 minus 5. So here in the very beginning of a class we have discussed about how to find adjoint and inverse of a 2 by 2 matrix by using the formula A inverse is equal to D minus B minus C A divided by AD minus BC. So substitute in this. A and D should be interchanged. So 1 and minus 5 is interchanging. So here I am interchanging minus 5 and 1. So minus 5, 1. 2 and 3. B and C values, the signs of these B and C values should be changed. So here we are having plus 2, plus 3. Here we should write minus 2, minus 3 divided by AD minus BC. So 1 into minus 5 is minus 5 minus B into C. 3 into 2 is 6. So like this you have to solve. Therefore A inverse is equal to minus 5 minus 2 minus 3 1 divided by minus 5 minus 6 is minus 11. So this is adjoint of A. This is determinant of A. So here in our question we are asking find the adjoint and find the inverse. So here adjoint of A and petti మీరు ఏం రాయాలి minus 5 minus 2 minus 3 1 అని రాయండి. నెక్స్ట్ ఇన్వర్స్ అని పెట్టి ఇది మొత్తం రాసేయండి. లైక్ దిస్ యూ హ్యావ్ టు డూ or you have to find adjoint and inverse for any 2 by 2 matrix. Let us discuss some more questions on this topic. So here our next question is A is equal to 3 4 7 9. Here also you have to find adjoint and inverse for the given 2 by 2 matrix. So first of all we have to write the formula A inverse is equal to adjoint of A divided by determinant of A, which is equal to the formula D minus B minus C A by AD minus BC. So here we have to substitute. A and D should be interchanged. So 9 3. Next 4 and 7, the signs of these numbers should be changed. So minus 4 minus 7 divided by AD minus BC. 9 3s are 27 minus 7 4s are 28. Therefore A inverse is equal to 9 minus 4 minus 7 3 divided by 27 minus 28 is minus 1. Therefore which is equal to ఈ మైనస్ 1ని లోపలికి తీసుకెళ్ళి మల్టిప్లై చేయండి. minus 9 4 7 minus 3. So this is the A inverse value for the given question. ఓన్లీ అడ్జాయింటే రాయండి అన్నారనుకోండి 9 minus 4 minus 7 3 అని రాస్తే సరిపోతుంది. దిస్ వాల్యూ ఈజ్ నోన్ యాజ్ అడ్జాయింట్ ఆఫ్ ఏ, దిస్ వాల్యూ ఈజ్ నోన్ యాజ్ డిట్ ఆఫ్ ఏ. దెన్ ద నెక్స్ట్ B inverse is equal to D minus B minus C A divided by AD minus BC. So which is equal to 3 and minus 3 should be interchanged. So minus 3 3. 2 and 2, the signs of these numbers should be changed. So minus 2 by A into D is 3 into minus 3 is minus 9. 2 into 2 is 4. So like this you have to do the answer for the given question. minus 3 minus 2 minus 2 3 by minus 9 minus 4 is minus 13. So this numerator value should be called as adjoint of A. Denominator value should be called as det of A. So by this we have completed 2 by 2 matrix adjoint and inverse calculation. Next we shall discuss about 3 by 3 matrix adjoint and inverse. Here our next question is find adjoint and inverse of a 3 by 3 matrix where A is equal to 1 minus 1 1 2 3 minus 3 6 minus 2 minus 1. So here A inverse is equal to adjoint of A divided by det of A అనే ఫార్ములా బాగా గుర్తుంచుకోవాలి. దిస్ ఈజ్ అవర్ మెయిన్ ఫార్ములా. So here first of all we have to find a determinant of A. Det of A is equal to plus minus plus 1 minus 1 1. So here I am using Laplace expansion. So Laplace expansion use చేసి determinant of A find out చేయండి. So here 1 minus 1 1 row 1 గా expand చేస్తే mod mod mod. Here we have to write the minors of 1 minus 1 and 1 elements. So minor of 1 is, if you cancel row wise and column wise corresponding to the element 1, then you will get 4 elements. So that 4 elements called as minor of 1. 3 minus 3 minus 2 minus 1. So the next minor of minus 1 is 2 minus 3 6 minus 1. Next minor of this third element 1 is 2 3 6 minus 2. 2 3 6 minus 2. So like this you have to expand. Now we have to simplify to get the answer for det A. Plus 1 bracket plus 1 bracket plus 1 bracket. So here minus into minus is plus. So 3 into minus 1 is minus 3. Minus into minus plus. 3 into 2 is 6. So here 2 ones are 2. Here I am using AD minus BC. 2 into minus 1 is minus 2. Minus 3 into 6 is minus into minus plus 18. Next 2 into minus 2 is minus 4. Minus 6 3 is 18. Here for all these 3 we have to use the same formula AD minus BC. The next simplify. 3 minus 3 minus 6 is minus 9. 18 minus 2 is 16. 16. 18 minus 18 minus 4 is minus 22. Therefore minus 22 minus 9 is minus 31 plus 16, which is equal to 15 minus 15, which is not equal to 0. So here minus 15 is not equal to 0. Hence the det A value is not equal to 0. Then we should call that matrix A as a non-singular matrix. Non-singular matrix. Since the det value is not equal to 0, then we should call that matrix as a non-singular matrix. For every non-singular matrix, there exists inverse for that matrix. Therefore, A inverse exists. So like this you have to find the det value in order to find whether the inverse of a given matrix exists or not. Then after we have to find adjoint of A. So here we have to find adjoint of A. Adjoint of A is transpose of a cofactor matrix. Already మనం డిస్కస్ చేసాము adjoint formula. Adjoint of A is transpose of a cofactor matrix. So first of all we have to find cofactor matrix, then after we have to do the transpose for that cofactor matrix in order to get adjoint of A. So here our aim is to find cofactor matrix. So in order to find cofactor matrix we have to follow one procedure, that is plus minus plus minus plus minus plus minus plus. First of all we have to write the signs as follows. Then we have to write the minors. Minors. Minor is always in mod. So like this you have to write the minors for given elements. Now the minor of 1 is 3 minus 3 minus 2 minus 1. Next minor of minus 1 is 2 minus 3 6 minus 1. Next minor of plus 1 is 2 3 6 minus 2. Next minor of 2 is minus 1 1 minus 2 minus 1. Next minor of 3 is 1 1 6 minus 1. Next minor of minus 3 is 1 minus 1 6 minus 2. Next minor of 6 is 1 minus 1 2 3. Next minor of minus 2 is 1 1 2 minus 3. Next minor of the last element minus 1 is 1 minus 1 2 3. Like this you have to write all the minors for the given elements in our question. After writing the minors, then we have to find the solutions for these minors by using AD minus BC for all these minors. So use AD minus BC formula to find minors. So plus bracket minus bracket plus bracket minus bracket plus bracket minus bracket plus bracket minus bracket plus bracket. So in these brackets we have to write the solutions for AD minus BC. So 3 into minus 1 is minus 3. Minus into minus plus 2 3s are 6. So minus 6. 2 into minus 1 is minus 2. Minus 3 into 6 is minus 18. Here we have to write plus 18 because AD minus BC. 2 into minus 2 is minus 4. 6 3s are 18. So minus 18. 1 into minus plus 1 1s are 1. So here minus 2 into 1 is minus 2. Here we have to write plus 2. 1 into minus 1 is minus 1. Next 6 1s are 6. So minus 6. 1 into minus 2 is minus 2. Minus 1 into 6 is minus 6. Here we have to write plus 6. So 1 into 3 is 3 minus 2 into minus 1 is minus 2. So here plus 2. 1 into minus 3 is minus 3. 2 1s are 2. So minus 2. 1 into 3 is 3. 2 into minus 1 is minus 2. So minus of minus is plus 2. So here for all these minus I have used only one formula, that is AD minus BC. Then simplify. Minus 3 minus 6 is minus 9. 18 minus 2 is 16. 16 into minus is minus 16. Minus 18 minus 4 is minus 22. 2 plus 1 is 3. So minus 3. Minus 1 minus 6 is minus 7. 6 minus 2 is 4. 4 into minus is minus 4. 3 plus 2 is 5. Minus 3 minus 2 is minus 5. Minus into minus is plus 5. 3 plus 2 is again 5. So this is known as cofactor matrix. So after getting the cofactor matrix, then we have to do the transpose for this cofactor matrix in order to get the adjoint of A. So here adjoint of A is transpose of a cofactor matrix. Therefore adjoint of A is equal to, here we have to do the transpose for this cofactor matrix. Transpose means all the rows should be written in columns. So first row is minus 9, minus 16, minus 22. Here I am writing as a column. Minus 9, minus 16, minus 22. Next second row should be written in column. Minus 3, minus 7, minus 4. Third row also we have to write in column 5, 5, 5. So this is known as adjoint of A. Therefore, after finding adjoint and also determinant, then we have to divide adjoint of A by det of A in order to get A inverse. Therefore, A inverse is equal to adjoint of A by det of A. Therefore, minus 9, minus 3, 5, minus 16, minus 7, 5, minus 22, minus 4, 5 divided by, so here the det value is minus 15. Already we have to find the det of A. So here we have got the det of A as minus 15. So like this you have to solve, or you have to find the det and adjoint of a given matrix. So here our last question, that is proof related to the properties of inverse. So here we have to verify that AB whole inverse is equal to B inverse into A inverse, which is one of the important property of inverse of a matrix. First of all, we have to find A into B multiplication. Therefore, A into B is equal to 3, 1, 4, 0 into 4, 0, 2, 5. So here first of all we have to multiply each row with every column in matrix B. So here 3 into 4 is 12, 1 into 2 is 2. So this is first element. Then in order to get second element, we have to multiply again first row with second column. 3 into 0 is 0, plus 1 into 5 is 5. Then we have to go for second row with first column. 4 4s are 16, plus 0 2s are 0. Next, second row with second column. 4 into 0 is 0, plus 0 into 5 is 0 again. Therefore, which is equal to 12 plus 2 is 14, 5, 16, 0. So this is AB. So after getting A into B matrix, then we have to go for AB whole inverse, which is equal to LHS. So D minus B minus C A by AD minus BC. Already we have discussed in the beginning of a class. So here A and D should be interchanged. 0, 14. Remaining two elements B and C, we should change the signs. Minus 5, minus 16. By A into D is 0 into 14, 0, minus 16 5s are 65. So here A into D is 0 into 14, 0, minus 16 5s are 80. Therefore, AB whole inverse is equal to 0, minus 5, minus 16, 14 divided by minus 80. Now we have to find B inverse into A inverse. B inverse is equal to 5 and 4 should be interchanged. We have to multiply with minus for 0 and 2. So 0 minus 2 by AD minus BC. 4 5s are 20 minus 0. Therefore 0, 5, 0 minus 2, 4 by 20. Then A inverse is equal to 0 and 3 should be interchanged. 1 and 4 should be multiplied with minus by AD minus BC is 0 into 3 is 0, minus 4 ones are 4. Therefore 0 minus 1 minus 4 3 by minus 4. Then we have to multiply B inverse into A inverse, which is equal to RHS, which is equal to 5, 0, minus 2, 4 by 20 into 0, minus 1, minus 4, 3 by minus 4. So 20 into minus 4 is minus 80. 1 by minus 80 into 5 0 0, 0 into 4 is 0. Next 5 into minus 5 is minus 5 plus 0 is minus 5. Next minus 2 into 0 0, 4 into minus 4 is minus 16. Minus 2 into minus 1 is 2, 4 3s are 12, 2 plus 12 is 14. So here LHS is equal to RHS, hence proved. So like this you have to prove the property of inverse of a matrix. So by this we have completed all the concept oriented questions in your exercise 3.5. So by this we have completed our total chapter matrices and determinants. So in the next class we are going to trigonometric chapter. Thank you all.